is Cam Wachtell. This is for Digital Systems. This is Lab 6, Adder Circuits, Part 1. So in this circuit, we have our XOR gate, which is our 74 of 86 AND chip, followed by our AND gate, which is our 7408 N. And then we have our OR gate over here as well, our 7432. Each one of them has a 5-volt power source going into pin 14 and a ground, each going to pin 7. Starting with our switch 1, which would be our A input. It is connected to pin 4 of our XOR gate, and it's also going to be connected to pin 5 and pin 9 of our AND gate. Switch 2, which is our B input, is connected to pin 1 of our XOR gate, and is also connected to pin 1 and pin 4 of our AND gate. Switch 3, which is our CN, is connected to our pin 2 of our XOR gate, but it's also connected to pin 2 and pin 10 of our AND gate. Our sum is connected to LED 1, which will be connected to our pin 6 of our XOR gate, and our C out is connected to LED 2, which is connected to our pin 6 of our OR gate. Now we'll go through our full adder truth table, beginning with everything at 0. So input A, input B, and Cin are all at 0. Our sum is at 0, and our C out is at 0. Now with A and B being at 0, and Cin being 1, our sum is 1, and our C out is at 0. Resetting. Next, we'll have B at 1, while C, N, and A are at 0. Our sum is at 1, and our C out is at 0. Resetting. Now, next, we'll have A at 0, while B and Cn are at 1. Our sum is at 0, and our C out is at 1. Resetting. Next, we'll have A at 1, while B and Cn are at 0. Our sum is at 1, and our C out is at 0. Resetting. Next, we'll have A at 1 and Cin at 1. Our sum is at 0, and our C out is at 1. Resetting. Next, we'll have A at 1, while B at 1 as well, and Cn is at 0. Our sum is 0, and our C out is 1. Resetting. And lastly, when A, B, and Cn are all at 1, both our sum and C out are at 1 as well.